Guys, it's Miss Alstrom, and here we go. So we did fundamental skills, we did exponents, properties of exponents, and factoring. Okay, uh, and those were the problems that were on your PP 1.1. I put up the properties of exponents so that if you need this little bit of section pre-workout of the problems, then it's going to help you out. Okay, so if you have the same bases, you see that the base A and A are the same, and there is multiplication in between the two bases. Okay, what you do is you add their exponents. Oh no, I don't want to circle that one. Okay, you add their exponents. Okay, if there is a base A with the power of m, or an exponent of m, and that entire number is raised to another power, okay, then you would have to multiply. So there is a multiplication between the m and the n. Okay. Now, if there are two bases and after the parentheses, around the parentheses, there is an exponent being applied, it's not called a distributive property. You are just applying that exponent to each of the bases. Okay, and notice that there is a multiplication in between A and B, and there will be a multiplication between the base A and B with the same exponents, applying the base. Okay, now a negative exponent is a location changer, or the reciprocal. Okay, so basically, if you had a negative exponent in the numerator, you would move the base and the exponent down to the denominator. Okay, remembering that the negative of the exponent now becomes positive. If you had a base and a negative exponent in the denominator, that would now go into the numerator, being mindful that that exponent is now a positive exponent. Okay, if you have the same base, one in the numerator, one in the denominator, you can take the exponents and you can subtract them. Or, like I was saying in class, you can think of it this way. When you need to bring this entire thing up to the numerator, then you have to take the negative of the exponent. So that becomes multiplication. That. And then you can use the product property, and it just becomes m plus negative n, which is a m minus n. And we just proved the quotient property using is it product property? Yeah, that's basically what you're doing. I mean, you could take a m, if it was like this, you could take this down to the denominator, 1 over a n, and then the negative exponent, and then just combine these two together and whatever it is, bring it back up. It doesn't matter. You get the same answer. Okay. Once again, this is just like, you know, what you had before. You could put a 1 on top of these, say that that's an exponent of 1, that's an exponent of 1. You can bring this to the top, or the numerator, the b, so times b to the negative 1. And then you can apply m to both. This is a derivative of, I believe that's a power property. Oh, no. Yeah. Something, yeah. Is it? Okay, anyways. So a m times b negative m, which is going to be a to the m over b to the m, which is the same thing as what you get if you just apply the m to both of the exponents. Now, the fun thing about exponents, you could play around, and you should just get the same answer. Now, exponent with a 0 is always 1, and you guys are wondering why. Okay, well, basically that tells us, is asking us, hey, if I multiply a by itself 0 times, what do you get? Well, a lot of you guys are thinking 0. But let's create a scenario where the exponent is 0. So for example, if we had a to the 1 over a to the 1. Okay, so that means there's one a in the numerator and one a in the denominator. And what does that simplify as? As 1. Now, if I take this and I actually use one of the properties, it'll be 1 minus 1. So that'll be a to the 0. The number that you get when you multiply the base by itself is 1, because it reduces down to 1. When we reduce something in a fraction form, 2 divided by 2 is not 0, it's 1. Okay, 0 is a very special number. Most cases, yeah, 0 is my favorite number. But anyways, this kind of proves, that's a little tiny proof to prove, and along with this, that's an algebraic proof to prove that any base raised to the exponent of 0 equals 1. Okay, good job. So let's move on to our problems. Okay, so in class I said treat this like a negative 1 times 9 to the second. So we're taking 9 and raising it to the second. So that is going to be negative 1 times 81, negative 81. Now this, you can treat it like negative 1 times 9 raised to the second, and we can apply negative 1 to the second times 9 to the second. So that becomes 1 times 81, and so that is a positive 81. Okay, here we have a negative. 3 times 3 is 9. 9 times 9 is going to be 81. And then we have 2 times 2 times, what is that? 2 times 2 times 2 times 2 times 2 times 2 times 2 is 4, 4, 4, 4 times 4 times 4. That's 16. 16 times 4, 16 times 4, 24. Is that 54? See. Let's just do it on our calculator. Where's my calculator? Okay, so that is 16 times 4. And then, yeah, negative 6. Oh, it's 64, not negative. And then, just got the magical calculator up here. And once again, for your test, you are going to have a sorry, I hear my cat meowing. Let's see. That is a negative 5184. Good job, good job. Okay. So we have same bases, right? So couldn't we use the properties? Okay. So that's going to be a 3 and 7 minus 3, so 3 to the 4th, which you could leave the answer that way. Well, it's 3 times 3 times 3 times 3, 9 times 9 is 81. Voila. Good job, good job. Okay, right here, same bases. I could take, what just happened? Just clicked on something with, what is that arrow? I don't want that arrow being there. Okay, I could just subtract the 2, or I could actually move this entire number up and make that exponent positive. times negative 7 plus 4. And you add the two exponents, keep the base. There you go. That goes back down to the denominator. Raise that negative 7 twice. That is a 1 over 49. There you go. There you go. Okay, next one. We apply. First, we could take the reciprocal and make that negative a positive. So do 4 over 5 raised to the second power. So that's 16 over 25. Voila. Good job. Okay. Let's see. Do I want to have a little fun with this? Maybe. Okay. So 3 to the 4 raised to the third power. Okay. Maybe I could take, do I want to do that? I mean, 16 is 4 raised to the second power. But then I would have to separate the negative out because negative 1 would have to work separately because it's not 4 raised to the second power is not negative 16. So I don't know if I want to do all that. So I'm just going to do that. What I was thinking was taking that negative 16 raised to the second and changing the base, okay, as possibly negative 4 times 4 raised to the second power and applying the 2 to both of the bases. I could totally do that. Yeah, negative 4 raised to the second power, 4 raised to the second power, and then somehow simplify that against 3 to the third and 4 to the third. Let's go ahead and try it that way and see what happens. 4 to the third. Okay. Whoa. And this is over 1, right? Over 1. And then, let's see. I see common bases here, right? And so that would mean 2 minus 3. So that would be 3 to the third times negative 4 to the second over 4 to the negative 1, or is to the 1, I'm sorry, to the 1, okay? And then I can go ahead and, I don't, see, with these, I like to have a little fun. 3 to the third times, I could further split that out like that, 4 to the 1, okay, and raise that, take that, raise it, 4 to the 1, and then this equals, let's see, I'm going to just keep that 3 to the third, and that's going to just become 1, negative 1 times, and then we have a 2 minus 1, so that's just going to be a 4 raised to the 1 power. Nothing in the denominator, guys. Okay, so that just simply becomes 3 times 3 times 3, which is 9 times 3, 27. 27 times 4. So, and once again, some of you guys are going to be way better at arithmetic than me. 27 times 4, 108. Okay, now have some fun with your exponents. Play around. Why not? Okay. If I'm going to use the exponent rules to my fullest abilities, let's go ahead and change this to a base 2. Base 2 raised to the second, which is 4. Now I'm going to apply the 3 to it, and then, oh, I have to put another bracket. I kind of don't want to do that. Let's just do it like this. 2 to the second, raise this to the third power, and then raise that to the negative 2. And then, I could separate out a negative 1 times 2 to the third power, raise it to the third. Okay, and all of these exponents, we just multiply. So let's go ahead and change the color. Let's make it blue. Okay, 2, and then 2 times 3 is 6. I think it's 6. 6 times negative 2, 6 times 18, negative 18. Let's just check. 2 times 3 times negative 2. Oh, wow, that's 6. This is completely wrong. This is why I have to use the calculator for arithmetic. Okay, and then I can take negative 1, apply it to the third power, and 2 to the third. 3 times 3 is going to be 9, right? Just didn't really need to put that in parentheses. You just multiply all the way across. So 2 to the negative 12 times negative 1 times 2 to the 9th. I could just add these two exponents. So I get 2 to the negative 3, negative 1. So whatever it is, it's going to be a negative. And 2 to the third in that denominator. So that's going to be a negative 2 to the 8th. Voila! Now, let's take a look. This is going to be 1. It's nice. Okay, I can move this up, entire number up. It's going to be a 1 times, is it negative 5 to the 1 times negative 5 to the second. So we add the two exponents. So 1 times negative 5 to the third. 5 times 5 is 25. 25 times 5 is 125, I think. 5 to the third. So negative 125. Voila! Good job, guys. Okay. Number 10. Now remember that all of the bases has its own exponent. Okay, so this is just basically negative 3. I mean, not, where did the negative come from? First of all, I'm going to change the color. Yellow. Okay, negative. No, once again, I put a negative. 7 times negative 3. I'm rearranging. And you can do that because there's multiplication, and that parentheses just means multiplication. Okay, so negative x to the 9th, x to the 4th, negative 21, x add the exponents, and x to the 13th. Good job. Number 11. Okay, let's rearrange this. Negative 9 over 4. Okay, times negative 16. A to the negative 2. A to the negative 3. B to the 7. And B to the negative 6. So whenever I was teaching exponent rules, and it got really difficult because there were so many variables and so many scattered bases, common bases, all throughout the numerator and the denominator. What I would just say is follow the base A's and their location, whether or not it's in the numerator or denominator. And then just look at the exponents. And basically with exponent rules, you're just adding and subtracting, or multiplying in some cases. And so I just said focus on what's going on with the exponents, and then you could just do it in your head if you're good at arithmetic. Or you could do it this way. Okay, so we have a positive. That's 16 over 1. That is going to reduce 1 and 4. So 9 times 4 is 36. Positive. This is a positive 36. Okay, and then you're going to get an a to the negative 5. and b to the 1. Now we just can't have negative exponents, so that's going to be 36b over a to the 5th. And I don't like using b's as variables, so that definitely show that that's a b. As I was saying, I would follow the a. A's in the numerator, a's in the numerator, so you just add the two. Okay, b's in the numerator, b's in the numerator. So you can do that in your head. 7 minus 6, negative 2 minus 3. That's negative 5. That goes in the denominator. Okay, that's a way for you to check. Separate out the bases. Okay, so let's go ahead and apply, or I could take this negative and make it a positive exponent by putting everything in the denominator, the entire. And there's different ways to do this. There's not one way that's right, but you're going to eventually get the same answer. Okay, and then I'm going to apply the 5th. See, we multiply the 4 and the 5, the negative 4 and the 5, negative 20, and d 25. Let's clean that up, clean the exponents so that, see, the 20 goes up. 2 to the raised to the 5th power is 32, and d to the 25th. Good job. Okie dokie. Okay, so we have a 24 over 3. This way, this is what I like to do. Okay, I like to just put a bar there and see what goes on the top. In the numerator, what goes in the denominator. 24 divided by 3 is 8. It's going to go in the numerator. And, I mean, you can think of it as subtracting. So negative 3 minus 5, which is plus 5s. So p to the 2nd. Okay. Or you can move it, the p to the 5th up here and p to the 3rd up here. It's up to you. Whatever works for you. Okay. And q, you can do it in your head. That's fine. If you need to do it this way and get rid of all of the negative exponents, it's up to you. Okay. R to the 0 is 1. And so we had 8 and then p to the 2nd and q to the 12th over r to the 4th. There we go. Good job. 14. Remember, 10 has its own exponent. The negative 4 has its own exponent. Okay, so I'm going to take that negative 4, the power of 1, and raise it to the 3rd power. Raise it to the 3rd power. Okay, 10 stays down in the denominator because its exponent is a positive 1. Move that exponent of, that base of m raised to the 5th power up to the numerator. And then I have a negative 4 times 4 times 4 times 4. 4 times. Okay, I'm going to use the calculator. So 4 raised to the 3rd power. And that's going to be a negative times a negative times a negative. So it's still going to be a negative. Negative 64 over 10 m to the 8th. I'm not done. 64 and 10 could both be reduced to 2. So that is a 32 m to the 8th over 5. Good job. Next. Before I actually apply the negative 3 to each of the, remember 2 and 4 both have its own exponent. Okay, I'm going to change it from a negative to a positive by taking the reciprocal. So everything downstairs comes upstairs, including the sign exactly as is. You are applying this negative to make that reciprocal. You are not doing anything with this negative 5, with that negative on that 5, okay? u to the fourth. So that becomes raised to the third power. You can simplify inside first if you want. Okay, yeah, let's go ahead and do that. So that's going to give you a 2. 4 divided by 2 is 2. And then we have a, let's see, u minus 4. So that's going to be u to the third in the denominator. And then v to the fifth in the denominator, raised to the third power. And then that is going to be u to the third. 3 times 3 is 9. V, 15. So 2 raised to the third power is 8. And guys, I am perfectly fine with this answer. U to the raised to the third power is the same thing as 8. There is no way other to simplify it. There is no other numbers. There we go. Good job. Okay. Let's see this blurry expression. Okay. I'm gonna go ahead and simplify. Okay. Inside. Okay. Before I raise it to the second power. 6 and 15. 6 divisible by 3 and 15 is divisible by 3. So that's going to be a negative 2 and a negative 5. Is that right? Yeah, that's right. Okay. And then r to the 6th. And remember, if that's confusing for you, I mean, you can write out r and you can write 6, 7 r's and see which one crosses out. Or you don't have to even use that quotient property. You can say r to the 1 and then move that r up here and make it a negative. And then say it's r to the negative 6 because you're adding 1 and negative 7, r to the negative 6. And that just goes down into the denominator. Okay. Negative 3 minus, I'm taking this exponent and this exponent, negative 3 is 3 plus, oh, negative 3 plus 3, which is 0. So s just becomes 1. Okay. So we don't have any s variables. So sad for s. Okay. It just went away as 1. Remember, 1 is sometimes the go-to. Everybody thinks 0 is the go-to. 0 is a very special number. Okay, 0 makes everything disappear when it becomes multiplication. And we're dealing with multiplication here. So remember, 1 is the one that keeps the identity of the number when you multiply it. It is called the multiplicative identity. We're not doing adding here. All of these bases are being multiplied. Okay, so the 1 has really no significance when you multiply with it. 0 has a huge significance when you multiply with it. 0 is a big equalizer when you multiply with it. Okay, anyways, so negative 2 raised to the second power, you are also taking care of the sign too. So negative 2 times negative 2 is going to be a 4. 5 times 5 is going to be 25. R. 6 times 2 is going to be 12. I don't think we can reduce that. And that's it. Good job, guys. Okay. Let's see. I don't see anything that I need to that I can simplify inside of this parentheses. I don't see anything I can simplify, so I just have to apply the 4 to every single base. So A, 3 times 4 is 12. Remember, these numbers have an exponent of 1. 4, B to the 4. If it helps, if there's no exponent, put a 1 on that as an exponent of the base. Okay, 6 raised to the second power. B, 3 times 2 is 6. A, 4 times 2 is 8. voila. Let's go ahead and make a big, I like to kind of, so 6, and then that's going to be 36. 36, a to the 12, b to the 6. 3 times 3 is 9. 9 times 9 is 81. And b, a to the 8th and b to the 4th. Now, you see these two numbers, 36 and 81. 6 right here is made up of a 2 times 3, and we're raising it to the second power. You could have done it that way. Okay, and you could have said, hey, it's 2 to the second times 3 to the second. Then you can clearly see that 3 to the 4th can simplify with 3 to the second, if you wanted. Okay, but if you didn't, that's cool. Okay, 36 and 81 are both divisible by 9. Well, what do you know? There's that 9. Okay, that's called the least common multiple. Okay, so we have a 4. Well, this 3 to the second and that 3 to the 4th. Whoops. This 3 to the 4th. I mean, the least common multiple. The least thing that they have in common is 3 to the second. Okay, so that we know that 3 to the second is 9. So 36 and 81 are both going to be divisible by 9 because that's the least common multiple. And then 9 and a to the 2 and 2, 4, and b to the second. Good job, guys. There we go, there we go. Number 18. Let's see. Whoa, 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 whoa. There's a lot going on here. Not really. But let's go ahead and figure it out. We're going to apply that 4 to each of the bases. Remember, -4 has an exponent of 1. So that's going to be a -4 raised to the 4th power. R to the 7 times 4 is 28. S to the -4. And then I'm going to take 16 times 6. I'm going to take these out and kind of rearrange that. R to the 1, R to the 1, that's going to be R to the second, 1 plus 1. S, -5, -2. When you add that up together, they're both going in the negative direction, and we're adding the distance. So -5, a little bit more towards -2 in the same direction. So that's -7. Okay. And then, let's see. I'm going to take this right here, this number right here, and I'm going to take the -1 out, raise it to the 4th power, which just becomes positive, and then 4 to the 4th power. Notice what I did. I took the -1 out with the 4, and I raised both of these to the 4th power. And then we have R 28 and 2. We subtract R to the 26th. And then S, that is going to be S to the 3rd. You can think of it as S to the -4th and S to the -7, and we're adding this to this, and it becomes S to the 3rd. Or once again, you can just take this and put it on the top. Take that negative exponent and make it positive, and it's still S to the 7. Okay? I need to erase this because it's not keeping up with math flow. Okay, so we still have that 16. 16, isn't it 4 to the second times 6? These we already got rid of. We took care of the R and the S. We simplified. Okay, so -1 times -1 times -1 times -1 is a positive 1. So we just have 4 to the 4th. Remember, 4 to the 4th and 4 to the second could be simplified. So it's just going to be 4 minus 2. Okay, R to the 26th, S to the 3rd, over 6. You could leave it this way. Okay, no, you couldn't, because you have to simplify still. So that is 16, R to the 26th, S to the 3rd, over 6. We can simplify 16 and 6 divided by 2. So that becomes 8r to the 26th s to the third over 3. Now, I know for some of these problems, I went kind of in weird ways, and it's just so that I could apply the exponent properties a little bit more. You don't have to do it this way. Okay, you could just take the numbers and simplify it, but I'm just playing around to show you that, hey, you can do it this way. Number 19. So I'm going to apply this negative exponent and just make it 2 by taking the reciprocal, but just location. Everything that was on the downstairs moves to the upstairs in its entirety. Do not change anything about it. Not even the negatives. Everything that was on the downstairs is going to move, upstairs is going to move downstairs. Do not change the sign. Now, can we clean stuff up in the middle? Or we can apply the 2 to each of these units, but I'm going to clean things up. Okay, so 5 stays. There is no other number. It doesn't have an exponent. Okay, C. C is going to be a negative and a minus -3, so it's going to be a 10. Or you can think of it as C to the 7th and move that C to the -3rd up to the upstairs. So you just add the 7 and 3. Okay. You can say D, -4. Okay. And then +1. That's still in D to the -3. So that goes on in the denominator. Or if you want to get rid of the exponents, there you go. You just switch the -4. The D with the exponent of 4 goes in the denominator. The D with the exponent 1 goes in the numerator. Okay? We still have to apply 2 to it. 5 raised to the 2nd power is going to be 25. See, 10 times 2 is going to be 20. 3 times 2 is going to be 6. Voila. Next. Looks like fun. Okay, so I guess we have to apply this exponent. We have to take these things out of the parentheses. The only thing that is restricting it, I think that's a multiplication in between. Or is that a minus? Is that a minus? Okay, that's a minus. So I have to take care of these two factors before addition and subtraction. And that's 2 terms. So -9 raised to the 2nd power. Don't forget to put a parentheses around that -9. Gonna make a huge difference. M, 6 times 2 is 12. N, 4 times 2 is 8. Okay. We have a negative and a negative. So that's going to be a positive. 6 times 7. That just left my mind. I don't have no idea what 6 times 7, 42. 42. And then we have M, add 12, N, 8. Okay, so that's 81. And we're adding it to 40. Let's see, M to the 12th, N to the 8th. Let's see if we can add these two. How do we add terms with variables in it? The variables have to be the same with the same exponent. Is it? Yes, for M. How about for N? Let's use a different color. Right here? Yes. So that means that we can add the two coefficients, which is 81 and 42. Okay, that's 3, 12. So 123 m to the 12th. Remember, the exponent stays as, the variable stays as is. Okay, good job. And then the next one, okay, we have two terms right here. That's separated by multiplication, so those are factors. Okay, 8x to the negative 9 plus, and I'm just keeping the negative 9 there, because if the other one didn't end up as x to the negative 9th, I can't add those two up anyways, okay? Or 8 over x to the 9th, where x to the 9th is in the denominator. So let's see, okay? So what I'm going to do is I'm going to put 1 over it, so that indicates to me that, all of that is in the numerator. And we have a negative 3 times 5, negative 15 over, that is going to be, that's going to move down to the denominator, and it's going to go along with this, so it's going to look like this, x to the third, y to the second. Okay, and then that means that that's going to be x to the 9th. That's in the denominator. The x is in the denominator. We're just adding the 6 and 3. Let's actually put it like this so you can see it better. Here, we have y to the second minus y to the second. They're both in the denominator. You can choose to move that negative exponent up to the numerator, but it's still y to the 0. So no, we can't do much. Okay, let's compare the two variables and their exponent. Is it the same? Yes, it is, because I could actually write the other one. This is x to the negative 9th minus 15 x to the negative 9th, right? I could bring that x, base x, and make that exponent a negative and bring it up to the numerator. So yes, are they the same? We have an x and an x, negative 9, negative 9. So we know we could take that coefficient and add the two. 8 minus 15 is going to be a negative, oh goodness, is it 7? X to the negative 9. We can't have any negative exponents, so that's going to go down to the denominator. So negative 7 x to the 9th is your answer. Good job, guys.